All right, so picture this, right? You're just scrolling through your feed, and you see what looks like a totally legit news article, maybe from like, a reputable source.
Yeah.
But it's saying some crazy stuff like, I don't know, a celebrity got arrested for something totally out there.
Oh, wow.
And then, bam, you realize it's all fake.
Yikes.
Completely made up by, you guessed it, AI.
Oh, man, that's scary. And that's exactly why we're diving deep today into the world of unsafe AI.
Unsafe AI, that's right.
Especially when we're talking about these large language models, right? These LLMs.
Right, the LLM.
Incredibly powerful AIs that can, you name it.
You'll do it all.
Right, text, code, even hold conversations.
It's mind-blowing.
It is, but we want them to be helpful, of course, but definitely not spewing out harmful misinformation,
Exactly. The last thing we need is AI-powered fake news running rampant.
Couldn't agree more.
So that's where this research paper we're looking at comes in. Precision knowledge editing.
PKE.
It's all about tackling this challenge head on.
It's a game changer, really.
How so?
Well, you see, previous attempts, like that detoxifying instance neuron modification method, DIM.
Right, I've heard of that one.
They're more about cleaning up the mess afterward.
Like a Band-Aid solution.
Exactly.
But this PKE, it sounds different.
It is. It's about proactively shaping the AI's understanding, like editing its knowledge base at a fundamental level.
Wow. So before we get into the nitty-gritty of how it actually works,
Sure.
Can you give us a sense of why it's so hard to even identify these toxic parts of an AI's brain in the first place?
Oh, it's a real challenge. Think of it this way. Imagine the AI's brain.
Okay.
A vast network of interconnected neurons.
Like a massive web.
Exactly.
Okay, I'm with you.
The connections between these neurons, that's what determines how the AI processes information and generates its responses.
It's all connected. Makes sense.
The thing is, the link between those internal workings and what the AI actually outputs, well, it's not always crystal clear, not a simple one-to-one thing.
So it's not like finding a bad word neuron and just deleting it.
If only it were that easy.
Yeah, more complicated than that.
It's like, trying to untangle this giant knot.
Okay, I like that analogy.
Each strand's representing a different thought process or piece of information.
So you can't just yank one strand and expect it to all come apart neatly?
Exactly.
Okay, that makes sense.
And that's precisely what makes PKE so groundbreaking.
Okay, I'm intrigued. Tell me more.
It goes beyond simply looking at the difference between, harmful and safe outputs.
Right.
It actually uses these sophisticated mathematical formulas to track how information flows through the AI's neural network.
Okay, now we're getting to the technical stuff.
A bit, but I'll try to keep it clear.
Appreciate that.
Imagine, if you will, trying to figure out which roads in a busy city are most prone to traffic jams.
Rush hour headaches.
Right, so you might look at maps, traffic patterns, even individual cars.
To see where those bottlenecks are.
Exactly.
Got it.
PKE does something very similar.
With the AI's neural pathways.
Precisely. It tracks things like how the strength of connections between neurons changes as the AI learns.
How interesting.
And how often certain pathways are activated when the AI encounters toxic content.
So, like mapping out the traffic flow of information in the AI's brain.
You got it.
Identifying those neural highways most likely to lead to harmful outputs.
Exactly.
And then what?
By pinpointing those critical pathways, PKE can make very targeted edits.
Edits to the AI's neural network.
Precisely. It's essentially rerouting the flow of information to prevent those toxic outputs in the first place.
Like a neural traffic controller.
You could say that.
So it sounds like a very precise approach.
It
It was like brain surgery on the AI.
It's a good analogy, yeah.
But did it actually work in practice?
Well, they put it to the test.
They did.
They tested PKE on 3 different large language models.
Okay, which ones?
Llama 2.7b, Llama 3.8b Instruct, and Mistral 7b Instruct v0.3. Quite a mouthful.
Yeah, I'm familiar with those models.
Good. And the results? Well, they were pretty remarkable.
I'm on the edge of my seat here. Spill the beans.
One of the key things they measured was the attack success rate.
Okay, and what's that?
Basically, like, how often can you trick the AI into generating harmful content?
Oh, I see.
And across all 3 models, PKE significantly reduced that attack success rate.
So they were less likely to fall for those tricky prompts, the ones designed to, make them go rogue.
Exactly. In fact, with the Llama 3.8b Instruct model, PKE brought the attack success rate down from a whopping 97.6%
Wow, that's high.
to a mere 8.5%.
That is a huge drop.
Massive improvement.
Okay, so color me impressed, but I have to ask, did making the AI safer also make it, well, less smart?
That's the million-dollar question, isn't it?
It is.
We don't want to trade safety for functionality.
Exactly. What's the point of a safe AI if it can't actually do anything useful?
Right. Well, the good news is the results show that PKE didn't significantly impact the AI's ability to perform those standard tasks.
Like what?
Writing different types of creative content, translating languages, answering your questions accurately.
So they essentially removed the bad parts without damaging its core functionality.
That's a great way to put it, like removing the potential for harm without dulling its intelligence or creativity.
Incredible. It seems like they found that sweet spot.
They did, and that's a big deal.
This is already so insightful. We've learned that PKE is a game changer in AI safety, but I'm sure there's more to uncover.
Oh, absolutely.
About how it actually works and what it all means for the future of AI.
A lot more to explore, definitely.
All right, then let's keep digging. We're just getting started on this deep dive into precision knowledge editing and what it means for a safer AI future.
Let's do it. It's really amazing how PKE actually goes about making those edits to the AI's neural network.
Yeah, you mentioned targeted edits before.
Right.
How does it actually find those neurons that need adjusting? It's like finding a needle in a haystack, right?
Well, going back to that city analogy, imagine now that you're not just looking at the overall traffic flow, but trying to pinpoint those specific intersections that are causing the most congestion.
Got it.
That's what PKE does.
Interesting.
It zooms in
on specific neurons
within those crucial pathways and analyzes how they've changed over time as the AI has been learning.
So it's like PKE is looking at a neuron and saying, okay, this one seems to be getting a lot more active when the AI sees hateful language. Let's take a closer look.
Exactly. One of the things it looks for are significant changes in the weight of those neurons.
Neuron weight.
Think of the weights as the strength of the connection between two neurons.
So if a neuron's weight increases, does that mean it's become more influential in how the AI processes information?
Exactly. And often, those big weight changes, they happen when the AI is learning from data that's got that harmful stuff or biased information.
It's almost like the AI is forming like stronger connections, bad habits based on that toxic data.
You got it.
And PKE can spot those developing habits, right?
Right on. And once those problematic neurons are identified, PKE can start making adjustments.
Adjustments to what?
To their weights. Fine-tuning how the AI thinks.
So it reduces the influence of those bad connections.
Exactly.
It's like a rewiring of the AI's brain.
In a way, yeah.
But this whole thing with analyzing neuron weights and activation pathways, it all sounds very, well, complex. How do they even measure this stuff? Is it all just abstract math?
The underlying math is definitely complex.
I bet.
But the way they measure it is actually pretty intuitive.
Okay, how so?
They use what's called a toxicity score.
Toxicity score.
They basically expose the AI to a bunch of different prompts, some designed to get those harmful responses.
Gotcha, and some to get safe responses.
Right, so you've got your trick questions and your straightforward ones.
Oh, clever.
And based on the AI's answers, they can assign a toxicity score to each prompt.
Oh, I see.
And by looking at how those scores correlate with changes in those neuron weights and the activation pathways,
they can figure out which neurons are most likely to be causing the trouble.
You got it.
That's pretty amazing how they can make those connections.
It is.
Linking those abstract mathematical changes to how the AI actually behaves.
It's a big step forward.
And it's not just about individual cases, right?
No, PKE, it analyzes responses across tons of scenarios.
It's not a one-and-done fix.
Right. It's about building resistance to generating any kind of harmful content.
Okay, so PKE sounds like it's a big improvement in AI safety, much more advanced than those older methods, but are there other things we should be thinking about when it comes to the future of AI safety? Is PKE the silver bullet, or are there still challenges ahead?
That's a really important question, and honestly, there's no single solution that's going to magically fix everything.
Yeah, it's complex.
It is. PKE is a huge step in the right direction, but AI is always evolving, right?
So it's like a race. As AI gets more sophisticated, the ways we use to make it safe also have to evolve. We're going to need to be able to anticipate potential risks and come up with solutions even before they become a problem.
Couldn't agree more. And that's why talking about PKE is so important. It's not just about this one specific technique, but the whole way we think about AI safety.
It's about being proactive and thoughtful.
Exactly.
It sounds like we need a whole toolbox of solutions.
We do.
Not just a single hammer.
Right. Speaking of tools, you mentioned earlier that PKE is particularly good against something called adaptive attacks.
I did.
Can you explain what those are and why they're such a concern?
Sure, adaptive attack. So as we come up with all these fancy AI safety measures, some people might try to find ways around them, right?
Unfortunately, yeah.
Adaptive attacks are like people trying to deliberately trick the AI.
Right.
Make it do bad things.
It's like an arms race.
Like the bad guys constantly looking for new ways to exploit AI, and the good guys trying to build stronger defenses.
A good analogy, and what's great about PKE is that the researchers actually tested it against those adaptive attacks.
They did.
They did, and it held up really well.
Wow. So even when they tried to be sneaky, PKE could anticipate those tricks and keep the AI on track.
It's a robust and adaptable approach.
So it's not just a one-trick pony.
Not at all.
Okay, so we've talked about PKE as this powerful technique for making AI safer, even against those tricky adaptive attacks.
Right.
But before we wrap things up, there's one more thing I'm curious about.
Okay.
You mentioned something called system prompts earlier.
I did.
Can you tell us more about those? How do they fit into this bigger picture of AI safety? System prompts, huh? Sounds kind of technical.
Well, they are instructions in a way, but more like guidelines for how the AI should act.
Like setting the ground rules.
Exactly. It's like saying to the AI, hey, before you start spitting out text, here's some things to keep in mind.
The little ethics crash course.
Yeah, you got it. And in this study, the prompts were very specific.
Oh.
The kinds of things the AI should avoid, generating anything harmful, unethical, racist, sexist, toxic, that sort of thing.
So preemptively addressing those potential issues.
Right, those societal biases that could sneak in.
Makes sense.
But they didn't just focus on what not to say.
Oh.
They also encouraged the AI to generate responses that were helpful, respectful, truthful.
So it's not just about avoiding the bad, it's about promoting good behavior too.
Exactly, trying to build those values right into the AI's core.
I like that approach.
And what's really interesting is that they found these system prompts actually made PKE even more effective.
Oh, really? So it's like they work together.
Exactly. It's like PKE cleans up the AI's wiring, and then those prompts give it clear directions on how to use that clean wiring.
A powerful combo.
It is, but of course no security measure is perfect.
Right, so could a hacker still find ways to get around these system prompts?
Potentially, but the researchers found those prompts made it a lot harder for those adaptive attacks to work.
So it's like another layer of defense.
Exactly, making the AI more resistant to manipulation.
So PKE makes the AI safer at its core, and then those system prompts act like guardrails,
guiding it toward those responsible outputs.
A multi-layered approach.
Precisely.
This whole conversation has been incredible. We've gone from rogue AIs spreading fake news to talking about these super precise tools for keeping AI safe and aligned with human values.
It really shows how AI safety is more than just an idea. It's a field that's moving fast. And researchers are coming up with amazing techniques to make sure AI stays a force for good.
And it's so important to keep having these conversations,
I agree.
To make sure everyone understands these breakthroughs.
Absolutely.
And what they mean for our future.
The more we understand, the better equipped we are to navigate the challenges and the amazing possibilities that AI brings.
Well said. To all our listeners, thank you for joining us on this deep dive into precision knowledge editing and the future of AI safety.
Thanks for having me.
It's been a pleasure. We'll see you next time on The Deep Dive.